Welcome to Spring LIB.
So in this question, we want to use Gauss's law to prove that for a cylindrical capacitor, which looks like this with the inner shell and outer shell, we want to prove that if the electric field is zero inside the inner shell or outside the outer shell. So there are two things we can do. First is just to look at this conceptually, because if you look at the cross-section of a coaxial cable, what will happen is that you will have all the positive charges at the outer surface of the inner cylinder, and you will have all the negative charges in the inner surface of the outside conductor. So what will happen is, in Gauss's law, we have E equals the surface charge divided by epsilon. But for anywhere, we need to look at the enclosed surface charge. If you draw a circle inside the inner cylinder, there will be no total enclosed charge because all the charge are on the surface of the inner cylinder because it's a conductor. A conductor does not have any charge inside it. All the charges are on the surface. So that is for this area. And if we look at any area that is outside of this larger cylinder, if we draw a circle like this, what happens is that we will see, because in a capacitor, the negative and positive plates will carry equal and opposite charges. So these two, all the positive charges in the inner cylinder will exactly cancel all the negative charges on the outside cylinder. So we look at the total charge of that is inside this Gaussian loop, we will see that the total charge is still zero. So regardless, when you have a Gaussian cylinder, a Gaussian loop, a Gaussian circle that is inside the inner cylinder or outside of the outer cylinder, you will have total net charge of zero. So there will be no electric field.